Hello, my name is Heather Rickard, and I'm a master's student at HSU. I'm working with Jeff Kane on a project looking at legacy hardwood mortality following prescribed fire. And I'm very honored to be a part of this fire congress and to record this video for you all. I am also very grateful to get the chance to work on this project in Karuk Aboriginal Territory. I would like to acknowledge the Karuk tribe and people for their presence and stewardship in this region here in the Klamath Mountains of Northern California. And I'd like to invite myself and those of you viewers to take action as part of this acknowledgement of Karuk land by giving to the Endowment for Ecocultural Revitalization, which I will do right after this talk. Legacy hardwoods, for the purpose of this study, and in my understanding of it, are these trees that have been stewarded by indigenous groups such as the Karuk since time immemorial, using grove-based broadcast burning and a family-based cultural practice. Trees, legacy hardwood trees are a source of important traditional foods and are central to tribal food sovereignty in this region. And they're important not only for food security, but for on many levels for individual and community well-being, and important for intergenerational learning. Bill Tripp, cultural practitioner for the Karuk tribe and director of the Department of Natural Resources, in this YouTube video, which I encourage you all to check out, talks about how this legacy madrone that fell following prescribed fire was likely great habitat for the Pacific fisher, which is another culturally important species. And he's pointing out that these trees are heavily encroached by Douglas firs, and the cavities have a lot of decay built up. So these trees are threatened by a whole slew of things, many of which are associated with the interruption of indigenous stewardship and fire exclusion specifically. They're heavily encroached to the point of overtopping and decadent in these areas. High fuel loading associated with fire exclusion has been related to legacy mortality, legacy tree mortality due to basal girdling, where fuels build up at the base and girdle the cambium from the outside. Also, tree mortality can be associated with crown scorch, associated with high fuel loading. Fine root consumption, finding a lot of fine roots in the surface here and in areas that haven't burned in a long time. Mortality has also been associated with reduced vigor, measured through like radial growth rate, and especially for hardwood trees, it would appear that the state of the scar or cavity of the tree, fire scar, including the buildup of decay, might contribute to mortality under low intensity fire conditions due to the heat generated on the insides here that can girdle the tree and cause structural failure. The goal of this project is to help identify what factors are associated with mortality, to assist tribal stewards to retain these trees as they restore their cultural burning practices. Research questions of this project I'll focus on in this presentation are: what is the mortality rate of legacy hardwoods at the stand scale in prescribed burn units? and what factors are associated with mortality at the tree scale. The species focused on for this research had mostly to do with their relative abundance, and they're the species that have been actively managed for in the region. We looked at 6 prescribed burn units burned within the last 4 years, an equal number of controls, and we conducted fixed area transects where we counted the number of hardwood trees greater than 25 centimeters DBH, and we noted the status of the tree, measured the scar dimensions, and took some other stand level measurements. This is our very preliminary results that I'll be presenting today. We'd like to do more analysis and collect more data, hopefully. The low range selected, 25 centimeters, was relatively arbitrary. We were hoping it would cover trees that were much smaller than legacy trees. However, we were surprised that the smallest trees with the pre-existing fire scars among all 3 species were as small as 25 centimeters. So it's possible without dating these trees through tree ring analysis that all of these trees could be legacy trees. But here you see the median size is about 39 centimeters. This is how we just coarsely grouped the trees and their status, 1 and 2, or living. And for the purpose of this analysis, and we tried to limit it to recently dead trees. So we just limited it to the 3s here. And initially, it would appear that the effect of prescribed fire at the stand scale is not statistically significant. However, it appears to be slightly elevated. We found that 42% of the trees we looked at had pre-existing fire scars. And among those trees that did die here, 59% overall had a scar, a pre-existing fire scar. 82% of trees that did die of inframadrone had scars. So at the stand scale, we use a generalized linear model, which these results show here, which were not significant, however, maybe slightly elevated. I just wanted to mention that when we did analyze at the tree scale, which I'll talk about more in a minute, treatment was significant. But again, at the stand scale, we thought, oh, well, let's break up the trees between sizes. So smaller trees and larger trees. Still, these trends were not significant, although it would appear that smaller trees had a more clear association with mortality due to prescribed fire. Again, this is still at the stand scale, so not significant. These general trends observed between species. So madrone, tan oak, and black oak. On the left is control, and on the right is prescribed burn. So then when we analyzed at the tree scale in the prescribed burn only areas, we did find that size was significant, where overall those trees that did die tended to be smaller. And we looked at size and species was even more significant, but different. So for madrone and tan oak, those trees that did experience mortality tended to be smaller. But with black oak, that opposite was observed. The most significant measure of scar size was scar width, where trees that did die tended to have larger scars. And the scar width associated with species was also significant, and showed that madrone, which, as we noted before, tended to have more scars, had larger scars, and the larger those trees that died tended to have larger scars than those that were living. Overall, tan oak scars were not very big and did not appear to really have an effect on mortality. And however, just slightly for black oaks, dead trees tended to have larger scars. We wanted to try like a very coarse geometric estimation, just looking at the cavity. We'd love to model the size of these cavities, but here is just, we looked at the ratio of the scar width to the DBH of the tree, which appears that it warrants further investigation because it was even more statistically significant with similar trends among species. Taking a closer look at madrone, which seems to have been driving a lot of our observations, and the smaller, so those trees that died tended to be smaller. And those trees that died also tended to have a greater scar width compared to the DBH. So in summary, move my face around, sorry. At the stand scale, there was no detectable difference in mortality. It was slightly elevated mortality in prescribed burn areas. And at the tree scale, treatment, that is prescribed burning, was found to be significant. Scar width was found to be significant, where greater the scar, the greater mortality with madrone and black oaks. Species was found to be significant. Size was also significant, where smaller trees had greater mortality with madrone and tan oak. However, the opposite was true for black oak. There's still a lot that Jeff and I are planning on doing. We're working on characterizing the basal fuels around these trees, also evaluating the effectiveness of fuels remediation treatments. We'd like to take a more in-depth look at the effect of legacy hardwood cavity on and condition and size on mortality. We'd also like to look at more tree-based estimates of competition associated with mortality. And we are hoping to engage in some value-based questions and community conversations around what constitutes a legacy tree and what levels of mortality are acceptable in this area. Thank you so much, Jeff, and everybody else who's contributed. And I'm going to right now go ahead and show my appreciation to the Karuk tribe. I invite you all to do the same. Thank you so much for your time. I actually have a couple more seconds, which is exciting. I just want to say, yeah, this is preliminary results, and I'm learning a lot, and I invite all of your input and questions and suggestions. Thank you so much.